G'day nerds. So now we're going to have a look at the hydrogen spectrum and the energy table. If you are unsure of what an emission spectra is, I've got another video on that. Please go back and watch that and then join us here. All right, so hydrogen spectrum and the energy table. This is to do with a very specific hydrogen emission spectra, and it's the hydrogen one. So the hydrogen emission spectrum is known as the Balmer series. He's a Swiss school teacher who's the first one to discover it in the visible section of the light, and you can see here are the lines that he discovered. And they represent, again, the visible part of it, and they represent the electrons which go up, and then they return to shell level 2 from their excited state. So they go up, like to whatever shell, it doesn't matter, and then they come back down to the second shell level, or principal quantum energy level, and that gives us lines in the visible spectrum. But we can see here, we actually have a bunch. We had the Lyman ones, which in the ultraviolet, they become particularly important to us. And you can see you can go up to 7, 6, 5, all the way down. This is for hydrogen too. We know hydrogen only has one shell traditionally, but we can see that when we excite it, it can do all sorts of weird stuff. And then we have an infinity, and that means these ones here, which have all been excited to the infinity level, what that actually means is they have left the building. No, they've left the atom itself, and we've achieved something called the first ionization energy. So this is the hydrogen spectrum right here. This is the emission spectrum. This is the absorption spectrum. And this is how, not hydrogen, but helium was discovered this way. And yeah, so we have very specific. So at this line here, we see is where we go from N3. So everything on this side is N3, this side is N2. Okay, so what does this mean? First off, we can see in the one that we have here, we can see 3 sets, but if we look up here, we can see all of them. But this is the spectrum that we have here, and we can see 3 sets or families, but again, these are all of the families. There's the Profund, Brackett, Passion, Balmer, and Lyman. It wasn't until, so these were discovered before Planck's quantum theory, but after that is when we could start to explain them. And in 1913, Niels Bohr worked out using quantum theory that the different lines that because there were different discrete lines, that electrons could only exist at those levels, and it couldn't exist in between. So that's why that's important. It tells us that. So the line emission, like spectra, they provide evidence of that, right? But they also show us, or they helped us work out that electrons were jumping from a higher level down. So because they jump from a higher level down, the law of conservation says that energy needs to be conserved. So some of that energy has to leave, and it leaves as a photon. And again, this is the Lyman, Balmer, Passion, Brackett, and Profund. And what we see over here is we start to see a bit more detail. So here we have the different jumps, right? So N infinity, that's when we reach the first ionization energy. So everything from there down, if it jumps to N1, it gives us ultraviolet light. That's the Lyman series here, and these are a really low energy level. Here we have N2, we get to the visible, and that's the middle energies, and that's your Balmer series. They're the really important ones for us generally. And then we have the infrared high, and that goes from anything back to N3. So just here we see the Passion series, right? So N6 back down. It releases the wavelength of 1094 nanometers and all the way down. The Balmer series goes from up. So the electron starts out here, gets excited, moves up to here, loses its excitement, and heads back down to its ground state in the N2. And so these are all coming down to N2. And then we have N1, boom, that's the Lyman series. All right, I hope that made a lot of sense. If you have any questions, put them in the comments below and we'll get back to you as soon as we can. Thank you for watching, and we'll catch you next time. Bye now.